loss of common logarithm log and the natural logarithm ln. So basically the loss for log and ln, they are the same, except for the log you do have to specify the base. So first of all, let me start with this. M and n are positive number and the base b is greater than 0 and the base b is not equal to 1. So let's take a look at ln. So for ln, when you have m times n in the parenthesis, that is ln m plus ln n, and then for the division inside the ln parenthesis, you have ln m minus ln n, and then for the exponent, this is the most popular and the most important law. You have to bring the ln down to the front. That is one of the main purposes of studying logarithm, is when you take the ln of a base raised to an exponent, you can bring the exponent in front of the ln. So you bring the n down, so the n now is in front of the ln. So you have n multiply ln of m. And this is true for the log. So let's take a quick look. So log, the only difference is you have a base b. So for log base b, m times n, that is a plus, so log of m plus log of n. For the division m divided by n, that is log of n minus log of n. And then for the exponent, m raised to the nth power, so you bring the nth power to the front, and then you have log base b of m. Now, what happens when you have a plus and a minus inside the log parenthesis? The answer is there is nothing you can do. There is no way to expand this. So ln of m plus n and the minus, it is what it is. There is nothing you can do. So you leave them as it is. And then what about ln m divided by ln n? And how about log of m divided by log of m? Same thing. There is nothing you can do. You can just leave it as it is. So what are these things for? These things are for expanding logarithmic expression. So let's say the first one, we have ln and then a square bracket x times y to the 6 times z minus 1 raised to the 8. That looks very complicated, but it is pretty simple. So let's get started. So the first problem is ln square bracket xy to the 6 and then z minus 1 to the 8th. This is true even though I change the ln to an log. So inside the square bracket, you have three factors multiplied together, right? The x, the y, and the z minus 1. So when you have a multiplication, do you see the first one? M times n, that is equals to ln m plus ln n. So we are going to do a plus. So this is a ln x and then plus ln y to the 6 and then plus ln z minus 1 and then raised to the 8. The next step is, do you see that there is a 6th power and there is an 8th power? Use the power rule, bring it down. I'm not saying the power rule for differentiation. When you have ln a base raised to an exponent, you can bring it down. So you can bring the exponent down. So you have ln x, bring the 6 down, so 6 times ln y, and then bring the 8 down, 8, and then ln z minus 1. This is it. This is the final answer. The z minus 1, it is just a minus, so there is nothing you can do. The z minus 1 stays as a z minus 1. All right, so let's take a look at number 2, the log base 2. Okay, let's do the log base 2. Let me switch to a different color. So log base 2, and then you have a square root x minus 1 divided by 7. You raise the whole thing to the 10th power. So using the power rule, the power law or power rule, you bring the 10 down. So you bring the 10 down to the front, and then log base 2. The x minus 1, that is a 1/2, right? So x minus 1, a 1/2 divided by 7. So this is log one term divided by another. Then you will be using the minus, right? Right over here. So you will be using the minus. Okay, so that is equals to 10, and then log base 2, you have x minus 1 to a 1/2 minus 10 log base 2 and then to the 7. So since the 10 is in front of the log, then the 10 is now stick to the log. And then one last step, you can bring the 1/2 down, right? So bring the 1/2 down, 10 times 1/2, and then log base 2 x minus 1 minus 10 I said 10, but I wrote log. So 10 log base 2 of 7. So 2 to the what power is equals to 7. We cannot figure out a perfect number, right? So just leave it as it is. Leave that as log base 2 to the 7. And then this one, the 10 and the 1/2, that is equals to 5. I'm going to save a line for myself. I will just erase this and then change that to a 5. Okay, so this is the final answer for number 2. And then number 3, we are back to an ln. Again, this answer is the same if you just use ln. ln and log, there is no difference in this type of problem. And then the next one, you have ln, and then the cube root of x to the 8th divided by 2y to the 6th. So the cube root is 1/3, right? So the cube root is 1/3. So we are going to bring the cube root down. So the cube root now becomes a 1/3. And then you have ln. So this one is the, you bring the 1/3 down, so there is no more radical. You have x to the 8th divided by 2y to the 6th, right? So this is ln 1 divided by the other, then you will be using a minus. So this is 1/3 ln x to the 8 minus 1/3 ln and then 2y to the 6th. So and then you bring the 8 down, so 8/3 ln x and then minus. So this is one term times the other, then that becomes a plus. But since there is a minus in front, then you have to use a parenthesis. So 1/3 ln 2 plus 1/3 ln y to the 6. Because when you distribute the minus, the plus becomes a minus. Okay, let's finish this up. 8/3 and then ln x minus 1/3 ln 2 minus, you bring the 6 down, 6/3 is equals to 2, and then ln y, and then this is it. So that is for number 3, right? I didn't number them, that's for this question. And then how about the next one, the one in square bracket? So let me copy the question first. So we have ln square bracket x squared times the square root of y to the 3rd divided by z, right? Okay, so this is a multiplication. This is a multiplication, then we will be using a plus, right? So we will be using ln x squared plus ln, so the square root becomes a 1/2, and then y to the 3rd divided by z, and then you bring the 1/2 down, so you have 2, bring the 2 down, x, and then you bring the 1/2 down, you have ln y to the 3rd divided by z, and then since this is one term divided by the other, then we will be using a minus. So 2 ln x plus 1/2 ln y to the 3rd, and then plus 1/2 ln z. And then you bring the 3 down, you have 2 ln x plus 3/2 ln y, and then plus 1/2 ln z. Okay, so we have these problems finished, and then I remember that we have 2 more, right? Yep, we have 2 more, so I don't want to keep going back and down. I'm going to copy this and then bring it down, so I don't need to going back up over and over again. Alrighty, the next one, we have log base 5, and then x to the 8 divided by y to the 9, z to the 10, a lot of fun. So top divided by the bottom, that becomes log base 5, and then x to the 8th minus log base 5, the bottom, y to the 9, and then z to the 10, and then we bring the a down, so bring the a down, log 5 of x, so this is a multiply, then we will be using a plus, so log base 5, y to the 9 plus log base 5, z to the 10, and then we bring the power down and then distribute the minus. So we have 8 log 5 x minus log base 5, bring the 9 to the front, and then a y minus 10 log base 5, and then z. That's it. And then the last problem, so we have ln, the 4th root of x to the 3rd times x to the 10 plus 2. Alright, so they are all x. I will just distribute the x to the 3rd to make the expression cleaner. So x to the 3rd times x to the 10, that is 3 plus 10 equals to 13th power, and then 2 x to the 3rd. And then next, we bring the cube root down, so the cube root is 1/3, and then we have ln x to the 13 plus 2x to the 3rd, right? Are we able to go any further? The answer is no. That's it. The plus, there is nothing we can do. There is no way to break this down. Okay, I want to take a look at what if I don't break this down. So what if I just do this? So if I have ln fourth and then x to the third and then times x to the 10 plus 2. How about this? I break this down to ln the fourth root of x to the third times the fourth root of x to the 10 plus 2. How about this? So that gives me this, right? So this is a multiply. So multiply means that gives me a plus. So we have ln the fourth, x to the third. How about this? How about x 3 over 4? Haha. And then plus ln x to the 10 plus 2. And then 1 over 4. And then you bring the 1 over 4 down. This is when you bring the fraction down. And then plus 1 over 4 ln x to the 10 plus 2. Okay, this one, the answers, they don't look the same. If you do a homework online, I'm sure the assistant will accept both. But which one is cleaner? I prefer to do this. This one is so much cleaner. But if you want to show off your work, show off that you fully understand everything, then just pick that one. All right. Oh, by the way, here, one thing that you may forgot. So let's say we have square root of x times y. That is the same thing as square root of x times square root of y. That's why I have the fourth root of x to the third times x squared plus 2. So that's why I can break this down into two pieces. All right. And then for that multiplication, that becomes a plus by the loss of ln. And then you bring down the power and then box that for the final answer. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video for me. If you are new to the channel, take 2 seconds to click the subscribe button down below. Appreciate for your help and support. I will see you all in the next one. Signing out.